NASA's twin Voyager probes, launched in 1977, astonished the world with their historic journeys to Jupiter, Saturn, Uranus, and Neptune. Even after 45 years, both probes continue their journey into interstellar space. Researchers, some of whom are younger than the spacecraft, are currently using Voyager data to unravel mysteries within and beyond our solar system. In many ways, NASA's twin Voyager spacecraft have evolved into time capsules of their era. They contain around 3 million times less memory than contemporary cell phones, transmit data at a rate about 38,000 times slower than a 5G internet connection, and each one uses an 8-track tape recorder for data storage. Despite these limitations, the Voyagers remain at the forefront of space exploration. What are they doing right now, and what will the Voyager spacecraft encounter next? Let's find out. These two remarkable spacecraft would never have taken flight if the stars hadn't aligned just right. In this case, the 4 largest planets in our solar system were the stars. Thanks to this rare alignment, a spacecraft could gain speed from the gravitational pull of each large planet it passed, like being pulled along by an invisible rope that suddenly snapped, sending the probe flying on its course. The drawback, however, was that this alignment only occurred once every 176 years. To take advantage of it, a spacecraft needed to be launched by the mid-1970s while the lineup was still in effect. As it turned out, NASA built 2 spacecraft to make the most of this once-in-a-lifetime opportunity. Launched just 15 days apart, Voyager 1 and Voyager 2, which were identical in every way, were sent into space in the summer of 1977. For nearly 45 years, these spacecraft have operated in space, sending data back to Earth every day from the farthest known planets of our solar system. They have outlasted every other spacecraft in history and have traveled farther. According to our best understanding of the boundary between the Sun's sphere of influence and the rest of the galaxy, they have entered interstellar space. They are the first human-made objects to do so and will likely continue to hold this distinction for decades to come. Not bad, considering the Voyager missions were initially intended to last only 4 years. The Voyager spacecraft's early observations of Jupiter's and Saturn's moons, provided to stunned researchers 40 years ago, revealed the presence of active volcanoes and furred ice fields on worlds that astronomers had assumed would be as inactive and crater-pocked as our own moon. Voyager 2 was the first spacecraft to fly by Uranus in 1986 and, 3 years later, by Neptune. It remains the only spacecraft to have traveled in this way so far. As pioneering interstellar probes more than 12 billion miles from Earth, they continue to surprise physicists with unexpected discoveries about this unexplored region. Their amazing voyage is nearing its end. To stretch the spacecraft's energy reserves as far as possible, NASA has turned off heaters and other non-essential components over the past 3 years, hoping to extend their operational lives to around 2030. It is a bittersweet moment for the scientists involved with the Voyagers, many of whom have been part of the mission since the beginning. They are now facing the end of a project that far exceeded their highest hopes. Voyager 1 arrived at Jupiter 546 days after its launch, in March 1979, while Voyager 2, which had taken a different route, arrived in July of the same year. Both spacecraft were built to be stable platforms for their Vidicon cameras, which used red, green, and blue filters to create full-color images. Since their rotation speed is over 15 times slower than the crawl of a clock's hour hand, the spacecraft hardly spin at all as they travel across space, reducing the risk of image blur. The spacecraft began transmitting the first images of Jupiter while still 3 to 4 months away from the planet, to the delight of standing room-only crowds at JPL. It was completely unexpected when Io appeared in color. Before the Voyager missions, it was believed that all moons in the solar system would look similar, drab and cratered. The incredible variety of moonscapes the Voyagers found near Jupiter and Saturn was not anticipated. The first sign that there might be more types of moons than astronomers had imagined came when the Voyagers were still about 1 million miles from Jupiter. One of their instruments, the Low Energy Charged Particle (LECP) detection system, picked up some unusual signals. Cameras on the Voyagers revealed that Io had active volcanoes. This small world, slightly larger than Earth's moon, is now known to be the solar system's most volcanically active body. The materials ejected by Io's volcanoes are what give it its hues, and the unusual ions that impact the instruments. Pelee, the largest of Io's volcanoes, has produced plumes 30 times higher than Mount Everest, with an ash field almost the size of France. The Voyager spacecraft captured more than 33,000 images of Jupiter and its satellites. Each photograph seemed to unveil something new. Jupiter had rings, and Europa, one of Jupiter's 53 named moons, had an icy shell that was cracked and is now believed to be more than 60 miles thick. As the spacecraft departed the Jupiter system, they received a gravity-assisted boost of 35,700 miles per hour. Without this, they wouldn't have been able to escape the Sun's gravitational pull and continue on to another star. The Voyagers diverged at Saturn. Voyager 1 passed by Titan, a moon shrouded in orange haze, and then turned north, away from the plane of the planets, after passing through Saturn's rings and enduring hundreds of impacts from dust particles. Voyager 2 alone went on to Uranus and Neptune. In 1986, Voyager 2 discovered 10 new moons orbiting Uranus, bringing the planet's total number of known moons to a growing count. 3 years later, it recorded the fastest wind speeds ever observed on a planet in the solar system, up to 1,000 miles per hour, while flying about 2,980 miles above Neptune's azure methane atmosphere. Triton, Neptune's largest moon, was found to be one of the coldest places in the solar system, with a surface temperature of just -391 degrees Fahrenheit, -235 degrees Celsius. Ice volcanoes on Triton expelled nitrogen gas and powdery particles 5 miles into the moon's atmosphere. If Carl Sagan, an astronomer and member of the mission's imaging team, hadn't been there, Voyager 2's images of Neptune and its moons would have been the last pictures ever taken by either spacecraft. NASA planned to turn off the cameras on both spacecraft once the Grand Tour was officially over, as there would be no more photo opportunities beyond Neptune, only the endless void and distant stars. Although the mission had been extended with hopes that the Voyagers would reach interstellar space, and was renamed the Voyager Interstellar Mission, Sagan pleaded with NASA officials to have Voyager 1 take one last set of pictures. As a result, on Valentine's Day 1990, the probe turned its cameras back toward the inner solar system and took 60 final images. Earth was captured in the most captivating of them all, known as the pale blue dot. At a distance of 3.8 billion miles, it remains the farthest image of our planet ever taken. Earth is barely visible in the photograph, hidden by dim sunlight reflected off the camera's optics, not even taking up a full pixel. Today, both Voyagers are so far from Earth that a one-way radio signal, traveling at the speed of light, takes nearly 22 hours to reach Voyager 1 and just over 18 hours to reach Voyager 2. They advance by 3 to 4 light seconds each day. The NASA Deep Space Network, a trio of tracking stations located around the world to maintain constant communication with spacecraft as Earth rotates, is their only link to home. The signals from the Voyagers are growing fainter as they move further away from us in both space and time. The world is incredibly noisy, everything creates noise, radios, televisions, cell phones, etc. Consequently, detecting these faint whispers from the spacecraft is becoming increasingly challenging. Despite their faintness, these signals have changed what astronomers expected the Voyagers would find as they ventured into the interstellar portion of their journey. It is important to note that the boundary of the solar system is not the same as the edge of interstellar space. The Oort cloud, a distant collection of comet-like objects held together by the Sun's gravity, may extend halfway to the nearest star. The star it will take at least another 300 years for the Voyagers to arrive at its near edge. However, interstellar space is far more accessible. Where the solar wind phenomena end is where it starts. The solar wind is a continuous outpouring of charged particles and magnetic fields that the Sun, like all stars, emits. Moving at hypersonic speeds, the wind blows out from the Sun like an inflating balloon, forming what astronomers call the heliosphere. The magnetic field of the Sun is carried into space together with the solar wind. The heliosphere's expansion is eventually restrained by interstellar matter pressure, forming a boundary with interstellar space that is preceded by a massive shock front known as termination shock. The heliopause is a border between our solar system and interstellar space, and estimates of its distance before the Voyager missions fluctuated significantly. According to GET, some of them were just assumptions. One early guesstimate located the heliopause as close as Jupiter. Garnett's calculations from 1993 put the distance at around 25 times further, between 116 and 177 astronomical units. $1 or 93 million miles is the distance between the Earth and the Sun. Garnett's projections from 1993 were accurate. Before one of the Voyagers ultimately reached the heliopause, about 20 years had elapsed. Voyager 1 had actually detected the anticipated rise in plasma density. Its plasma wave detector had inferred an 80-fold increase. But there had been no indication of a shift in the ambient magnetic field's direction. Shouldn't that change have been apparent if the vehicle had traveled from a place where the magnetic field originated from the Sun to one where it came from other stars? That was a shocker. In November 2018, Voyager 2 arrived at the interstellar seashore but did not notice any magnetic field changes. When the spacecraft reached the heliopause at 120 astronomical units from Earth, the same distance reached by its twin 6 years earlier, it added still another riddle. All theoretical models predicted that the heliosphere should ebb and flow in time with the Sun's 11-year cycle, but this did not fit any of them. The solar wind ebbs and flows at that time. When Voyager 2 arrived, the solar wind was at its strongest, and if the predictions were accurate, the heliopause should have been further out than 120 astronomical units. Theorists' models of the interaction between the heliosphere and the interstellar environments are getting more intricate now that the Voyagers are providing them with some actual field data. According to the general image, our Sun left a hot ionized zone and entered a patchy, partially ionized section of the galaxy. The hot zone probably developed as a result of a supernova, an ancient star nearby, or perhaps several, exploded at the end of their lives, heating the surrounding area and removing electrons from adjacent atoms in the process. One way to conceptualize the boundary enclosing that area is kind of like the seaside, with all the water and the waves whirling and mixing together. Magnetic fields twist and turn because we are in that sort of tumultuous area. Although the degree of turbulence observed can vary depending on the method of observation, it is not like the smooth magnetic fields that theorists typically prefer to draw. As a result of the heliosphere's influence on the interstellar medium, the Voyager's data reveal numerous small-scale changes near the heliopause but negligible field variations at vast scales. It is anticipated that the spacecraft will eventually leave those turbulent shells behind and come into contact with a pure interstellar magnetic field. Saying goodbye to these innovative spacecraft won't be simple. Seeing things come to an end is difficult. There are currently 5 operational instruments aboard Voyager 2 and 4 on Voyager 1. They are all propelled by a mechanism that transforms heat from plutonium's radioactive disintegration into electricity. But NASA has been forced into triage mode as a result of the power output diminishing by roughly 4 watts annually. The Voyager's adventures will continue even when they are entirely silenced. Voyager 1 will pass Proxima Centauri, our closest neighbor star, in 16,700 years. Voyager 2 will follow 3,600 years later. After that, they will spend millions of years orbiting the galaxy long after our Sun has disintegrated and the heliosphere has vanished. Not to mention one pale blue dot, they will still be there, largely undamaged. They might be able to deliver a final message at some point throughout their journey, however, it won't be broadcast over the radio. If it is, it won't be by humans. 2 recordings, another form of antiquated technology, are used to convey the message, but not your typical plastic version. These are formed of copper, have a gold coating, and are enclosed in aluminum. Images and noises intended to provide a feeling of the world the Voyagers came from are encoded in the grooves of the golden records, as they are known. There are 90 minutes of music, including Bach's Brandenburg Concerto No. 2 and Chuck Berry's Johnny B. Good, as well as images of kids, dolphins, dancers, sunsets, and sounds of crickets, rain, and a mother kissing her child. Jimmy Carter, who was President of the United States at the time the Voyagers were launched, also left a message. We cast this message into the cosmos, it reads in part. We hope someday, having solved the problems we face, to join a community of galactic civilizations. This record represents our hope, determination, and goodwill in a vast and awesome universe. Thanks for watching another episode of Space Discovery. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.